Hi friends, welcome to the KSET channel. Today we have to discussing some of the objective types questions in the case of wave mechanics. These are all useful for the KSET and also for the PGCETs for physics subject. So first we have to see the first question. First, quantum nature of light emerged in an attempt to explain. First one, it is answer is black body radiation. Absorptive power of the perfect black body. Second question is absorptive power is complete. That's one. That means black body it absorbs any radiation is falls on it. It completely absorbing that one. That radiations. Next, Wien's displacement law, lambda m into t, which is equals to constant. According to Wien's displacement law, the intensity maximum energy distribution curve shifts into the increasing temperature. So temperature increasing, in this case lower the wavelength. It means lambda m into t, which is equals to constant 1, and lambda m we have to increasing the temperature which is equals to constant divided by lambda m. So lambda m means wavelength will be decreases. Next, fifth question, for standing electromagnetic waves of the frequency nu, the number of oscillations is proportional to, that is nu square is the answer. Next, at the temperature T, the average of energy of an oscillator per mode of vibration, which is equals to h nu divided by e to the power of h nu by kt minus 1. Minus 1. This one B is the answer. Next, the radiation of the black body is an electromagnetic wave. The radiation of the black body is an electromagnetic wave. Next, 8th question, the total energy radiated per unit area per unit time from the surface of the black body at temperature T is proportional to T power 4. This is Stephan's law. Next, 9th question, Wien's radiation could explain the distribution of energy in spectrum of the black body radiation in the region of lower wavelength. C is the answer. Next, Rayleigh-Jean's law could explain the distribution of the spectrum of the black body in the region is longer wavelength. B is the answer. Next, 11th question, failure of the classical theory to explain the energy distribution in the spectrum of the black body radiation is due to the assumption of radiation energy is it's continuous. Next question, ultraviolet catastrophe leads to an accumulation of radiant energy in the region of shorter wavelength. That is B is the answer. Next, in the limit of the high wavelength, Planck's law of radiation is reduces to Rayleigh-Jean's law. Next, 14th question, in the shorter wavelength region of the Planck's radiation will be reduces to Wien's law. High wavelength reduces to Rayleigh-Jean's law, and shorter wavelength reduces to Wien's law. Next one, all radiation laws from the classical concept should be shown as in special case of the Planck's law. Next, Planck's law of the radiation assumes as the radiant energy is discrete, means it is not in continuous. Discrete means n times E is equal to nh nu. So in next question, 16th one, Planck's law of the radiation. Next question, the rest mass of the photon is h nu divided by c square. A is the answer. Next, 18th one, I am telling the wrong. Rest mass of the photon is 0. Rest mass of the photon is 0, and the mass of the photon of the frequency nu of the velocity of light. In this case, this one is an h nu divided by c square. C is the right answer. Next to 19th one, energy of the photon in the frequency, that is term is h nu c. Energy it is in the term of h nu c. Next one, the momentum of the photon having an with velocity c is p is equal to m into c. Next, photoelectric effect is in light energy is converted into an electrical energy. C is the right answer. Next one, 22. If the intensity of the incident light is doubled, intensity is doubled, the number of photons is also doubled. Number of photons will also double. B is the answer. Next, 23rd, the maximum kinetic energy ejected photoelectrons depends on the energy of the incident photon and the work function of the material. So D is the answer. A and B both are right. Next, stopping potential of the photoelectron, which depends on the frequency of the incident radiation. Next, 25th question is photoelectric effect does not occur. Photoelectric effect does not occur in the frequency of nu of the incident radiation is, this one is B is the right answer. Nu is less than nu naught. Next question, 26th one, the critical wavelength of the material 5200 Angstrom is emitted to an metal be irradiated of the monochromatic wavelength is, in this case, 50 watt UV source. Next question, 27th question, the work function of the photosensitive material 3.3 electron, the threshold frequency is 8 into 10 power 14 hertz. 8 into 10 power 14 hertz. A is the answer. Photoelectric effect is instantaneous process. Instantaneous means it changes into the with respect to time. After the 29, the energy of the photon, which energy h nu can be transferred into the free electron rest energy, that is less than h nu. Next, the dimension of the Planck's constant is equals to momentum into length. Momentum into length. C is the right answer. Next, 31 question is, if the view of the quantum theory of the photoelectric effect as a result of collision of a photon and free electron collision is an elastic. Next one, elastic means before and after collision, kinetic energy and the linear momentum of the particles remains same or constant. Next, 32 question, Compton shift will be depends on the angle of scattering. That is A is the answer. Next, 33 one is magnitude of the Compton shift will be maximum at the angle of scattering is 180 degree. Next one, Compton shift household object is not absorbed in the because of mass is very large. Mass is very large. That is B is the answer. B is the answer, not for NC. B is the answer. Next, Compton effect is absorbed in the target is free. Next, 36th question, Compton effect of the kinetic energy of the recall electron will be derived from energy of the incident photon. B is the right answer. B is the right answer, not for ND. B is the right answer. Next, Compton shift is equals to delta lambda is equals to h divided by m naught c into 1 minus cos theta. That is B is the answer. Next one, the Compton wavelength will be given by, that is h lambda c is equals to h divided by m naught c. Next, visible light is used for the Compton shift will be 0. So, visible light having a more wavelength that cannot be obtained in the case of Compton shift. Next, 40th question, if the visible light it can be used for the Compton scattering shift will be 40, that is 0. C is the answer. If the Compton effect is transferred, energy becomes maximum angle of scattering of the photon, that is 180 degree. Next, X-rays photon having a wavelength 0.3 angstrom undergoing a 60 degree Compton effect. The wavelength of the scattered will be 42 one is in 0.3120. In this case, we have to applying the Compton shift formula. We have to getting an answer. After that, the scattered wavelength means delta lambda, which is equals to lambda dash minus lambda. So lambda dash we have to know, that is equals to delta lambda value minus plus incident wavelength lambda. We have to getting an answer for the B. Next, Compton effect is linked to supporting on the quantum theory only. Next, to 44th question is the delta lambda will be Compton shift of the mass m of the scattering target is delta m is inversely proportional to the 1 mass anta ಹೇಳ್ತೀವಿ. Mass, that is C is the answer. Next one, Bohr has atom model postulated quantization of angular momentum. Next, Bohr's atomic model assumes that only certain values of the angular momentums are possible. That is A is the answer. Next, 47th one, the orbit of the electrons in hydrogen atom are closely spaced for n smaller values of n. That is C is the answer. Next, Bohr's theory of the hydrogen atom discoded. It's a principle of classical electrodynamics. Radius of the Bohr's atomic first orbit is 0.529 angstrom or 0. Next, 50th question, the number of revolution of an electron in an hydrogen atom in the excited state is 8.3 into 10 power 6. C is the answer. Next, velocity of the electron in the first Bohr orbital is me to the power of 4 divided by 4 epsilon naught square h cube. Next, 52nd question, velocity of the electron at the second orbit is 1.1 into 10 power 6 is the answer. B is the answer. B is answer B. Next one, Bohr discarded the quantum number of n is equal to 0 because of the electron having n for n is equal to 0 and r is equal to 0. Electron would have been go to the nucleus is impossible. So these questions, in some questions at least one question should be asked in the PG CETs and KSET also. Thanks for watching.